Yo, what to the up, peeps? Here is a quick video going through the solutions to the Google form. Just want you to watch this, kind of make it quick so we can be super refreshed on solving or graphing of polynomial equations and how to write the equations, how to determine the equations that you did from last year. And so you are experts, so we can hit the ground running when we do this stuff in class. Okay? Let me zoom in a little bit here. Okay, so here's problem number one. Which equation could describe the graph below? Oops. It is this one right here, option 2, x plus 1 squared, x minus 2. This is factored form. Any graph that finishes by going up will have a positive leading coefficient. This is an odd degree, remember? Odd degrees have different directions, even both are up or both are down. So this would be a positive, this would be positive. Again, if it finishes up, it's positive, just like a line, just like a parabola. An odd one that finishes down is negative, so these last two here are negative. In this case here, we have our roots here. Remember the difference here? This root goes through. I called it a shoot through. I got that from Mrs. Miller. But if it goes right through, it's kind of like a line. That's going to be the factor to the first power. Remember, this is a positive 2, but inside the parenthesis, it is the opposite. So it is x minus 2. Over here on the left, this is a bounce back. The blue is kind of like a parabola. It's not a parabola, but it's kind of shaped like a parabola, which is squared. So this factor or this root is squared, so x plus 1, it would be squared. So remember, you're looking for a bounce back would be squared, a green shoot through. And if you recall, if we had graph, and I'm just making something like this, that would be whatever the factor is cubed, kind of like x cubed, whether it's going up or let's say if it's going down, if it crosses like this, that's going to be the factor cubed. Okay, so here's where we have the x plus 1, the blue one is squared because it bounces there, and then the green one at 2 goes right through. Okay, on to problem 2. Which of the graphs is the following function? It would be option 3 right here. I'll tell you why and why not. It's not the other ones. Now, we can't factor this. Well, we could factor this. No, we can't actually because this is not a 3. It's got to be half of this. So anyway, we'll just look at the degree. It is an even degree, x to 6, so they're both going up. The first degree is, or first term is positive, so therefore both of them will be going up. So we can eliminate everything basically. This is an even degree, but it's a parabola. It's got a negative leading coefficient because it's going down. This is number first one is an odd degree. It's going up, but it's an odd degree, so it's not x to 6th. This last one, this is an even degree as well, but it's got a negative leading coefficient because it finishes down. So therefore, we are left with option 3. By the way, one of the limitations on some of the applications and programs we use, for whatever reason, they don't put arrows on the end of this right here. But you can assume there are arrows that goes to show that it goes and it is continuous. All right. 4, even degree, odd degree, and positive or negative leading coefficient. First of all, they're going in opposite directions, which means it is an odd degree, very similar to a line. You just have to worry about a line or parabola. We know a line, whether it goes up or down, goes in opposite directions. That's an odd degree. Any even degree is going to behave like a parabola, both going in the same direction, whether up or down. So this is an odd one, negative leading coefficient because it finishes. Odd degree, negative leading coefficient. Hope you're doing well so far. All right, give the coordinates as relative max and min, or just a relative minimum here. Remember, relative minimum just means a low point in a certain area. This graph goes forever and ever, so there is no lowest point or absolute minimum. But when it says a relative min, you just look in a certain area where it bottoms out in a certain area. So it's this point here. It is 0, 2. If it marked it as wrong, don't worry about it. I try to put this in here because if you put in like 0, and you put like this, 0 space or comma, then a space 2, it could mark that wrong. So trying to eliminate having to put in 75 different combinations. If you have 0, 2, you're fine, and I will recognize that. I'll be looking at each individual form to make sure you didn't get it marked wrong if it was correct. Now, where does this graph appear to be increasing? It is here in this section here. And just remember, we are always writing in terms of x. So where it starts increasing, where it stops increasing. So the x value, and this is where x equals. So the x value of this first point right here is at 0. The x value of this point right here is at 4. So it's 0 to 4. If you ended up putting this here, I'm not going to worry too much about it, but we always use parentheses because technically at the point it's not doing anything. It's over the interval. So that's why it's 0, 4. It's not 2 to 4. Happens to be 4 comma 4, but it's not 2 to 4. We are not talking the y values. We are talking the x values. All right. Which one doesn't belong? Let me zoom out here. A couple different, I came up with 3. Let me zoom out a little bit more. Your eyes are better than mine. You'll be able to see the tiny stuff there. So if you said A doesn't belong, I put the A is linear, everything else is non-linear. That's perfectly fine. By the way, again, assume that there are arrows in the end of all these here. They can do everything there. I'm not sure why they can't figure out a way to get it. Or you could have put C, because C has a negative leading coefficient, because that finishes down. Every other one finishes by going up. This one doesn't. You could have even put D. That D is the only one that has a double root. Everything else has a single root. So those are 3 that I came up with. My guess is most of you had negative leading coefficient. Maybe that would be your second choice. This would be your third, but if you had one of them, that's perfectly fine. And given the equation here, let me zoom in. All right, so what you did, I just took the roots here, x equals 4/3. Move this over here, so 3x equals 4, then subtract the 4, put that in your parentheses form. So that is your parentheses form of the root x equals 4/3. Same thing if x equals 5, that means x minus 5 equals 0. So if you just show that, it'd be x minus 5 equals 0. It works our way backwards to that. And then as far as these here with our i's, I root 3, I put the negative back inside, so I kind of move the I back in there, so it's negative 3. And remember, I mentioned here that imaginaries always come in positive and negatives. In this case, getting rid of the square root by squaring both sides. So that's how we get x squared equals negative 3. Then we move that over, so then theoretically it's x squared plus 3 equals 0. That's how you first start solving this. But in the parentheses, it would be x squared plus 3. Does not matter what order you put it in. I just have it in this order because that's the way it was here. But if you put the x squared one first, that's perfectly fine. That's how you rewrite them into the parentheses form. And okay, this one right here, just had to explain this here. This you factor out of 3. We factor this correctly. Here's x squared plus 4 gives us positive negative 2i, x squared plus 2. And again, most of us are very good with that. But just be careful. If you factor a number out, that doesn't give you an extra solution, only if it has a variable. So this one would be incorrect. And I believe that's it. All right. Thanks for watching, even though you had no choice if you wanted to get credit for it. Peace out.